We're going to apply what we did on Friday with ratios and proportions. We're actually going to be solving some proportions using geometric figures. So some vocabulary, similar polygons. So similar polygons are polygons that have the same shape but different sizes. So congruent meant same shape, same size. Similar means same shape, different size. So blown up or shrunk. Okay. For polygons to be similar, there have to be two things. Two things are required. First, corresponding angles of the similar polygons are congruent. And the second requirement is that corresponding sides of the similar polygon are proportional, which means that they satisfy that proportion. So when we cross multiply, we get the same thing. The math symbol for similarity, it's kind of, remember, congruent is equals with the little squiggly over it. We call that a tilde. Similar is just the tilde without the equals. Okay. So look at the first example. What angles must be congruent? What are examples of the ratios of the sides that must all be the same? So these two are similar quadrilaterals. They both have four sides. And believe it or not, if you look at it really closely, this one is just getting blown up to get to the second.
It's like 2 times out.
Mm-hmm. So the angles have to be congruent. Well, all of the corresponding angles must be congruent. So angle B is congruent to angle F. Angle C is congruent to angle G. Angle D is congruent to angle H. And angle A is congruent to angle E. So corresponding angles are congruent. Corresponding sides aren't congruent, they are proportional, which means if we find the ratio of this side to this side, so if we find the ratio of AB to EF, that will equal the ratio of BC to FG, which will likewise equal the ratio of CD to GH, which will equal the ratio of AD to EH. Now notice these ratios would be equal even if I flipped them all. So when you're writing out these ratios, it doesn't matter which one goes on top unless you're told specifically ratio of ABCD to EFGH. Okay. Now the scale factor is what Justin was referring to when he said this one looks like it's twice as big as the first one. The second one looks twice as big. The scale factor is the ratio of the lengths of corresponding sides. So one of these fractions, if we actually evaluate it, that is the scale factor. Okay, we call that scale factor. With similar polygons, the scale factor is consistently the same, meaning it's always the same, regardless of which ratio we choose. So if I choose the green one, we get the same answer as the red one. Okay? It doesn't really matter if they're similar figures. However, if there's even one that's not the same, like let's say I did AD over EH, and that wasn't the same as the other three, then these would not be similar figures. Okay? So example 2 says, using the similar polygons, determine the scale factor of quadrilateral EFGH to quadrilateral ABCD, and show the scale factor is the same regardless of which ratio is used. So this is what I mean when I say the order, quadrilateral EFGH to quadrilateral ABCD. So whenever we write this, it's kind of like A to B. So our lengths on EFGH will be on top of the ratio. ABCD will be on bottom of the ratio. Okay, so we're going to do... well, start with AB. I'm sorry, EFGH will be on top. So let's do EF to AB. All right, so we would have 22 to 11. Now, what is 22 divided by 11? Okay. Now let's do FG to BC. So we'd have 18 over 9. So 18 to 9 gives us 2. 6 to 3. Well, 6 divided by 3 is 2. And 28 to 14 is 2. And so we have a scale factor. I'll say scale factor, which from now on I'll just write SF of 2. So the scale factor of quadrilateral EFGH to quadrilateral ABCD is 2. Which is what Justin said, the larger one is twice as big as the smaller one. Example 3. So read example 3 to yourself and figure out what is different between example 3 and example 2.
It's by the way, instead of 22 over 11, wouldn't it be 11 over 22?
Okay, so it's reverse. It's ABCD to EFGH. So instead of 22 to 11, it'll be 11 to 22. Okay. Now what is 11 over 22? What does that reduce to? So use your calculators. You get a half. And so the scale factor of quadrilateral ABCD to quadrilateral EFGH, I call it SF, is a half. Did I have to use 11 over 22? What else could I have used?
9 over 18.
9 over 18. What would 9 over 18 give us?
Half.
3 over 6? 14 over 28? Okay, so it doesn't matter which one you use. If you already know they're similar and you're looking for scale factor, you just need one side from each one. You need one side on this one and a corresponding side on this one. Determine if these two triangles are similar. So there's two criteria for them to be similar. Notice not congruent. We can tell by looking at it they're not congruent. We're looking for similarity. So the first criteria is all the corresponding angles have to be congruent. So angle C, is angle C congruent to angle F? How do you know?
Because they're both right.
Okay. Is angle A congruent to angle D? How do you know? But how do we know they're congruent?
No.
Yeah, they both have a little arc. That's a congruency mark. So they're congruent to each other. And what about B and E?
Congruent because they have to.
Okay, so since all three have to add up to 180, these two add up the same as these two, right? So they must be supplementary to, or must be congruent to each other. Okay, so we've got all the corresponding angles congruent. The other part is all of the corresponding sides must be proportional. So 3 to 9 must equal 4 to what? 12. And then we've got 5 to 15. And now I put the equals kind of tentatively, like, well, they may not actually be equal. I put that to remind myself they need to be. So 3 divided by 9, we put that into our calculator or not, but it reduces to 1/3. 4 divided by 12 reduces to 1/3, and 5 divided by 15, 1/3. So the triangle. So we have congruent angles, proportional sides, and so the triangles are similar. I'll say similar. Triangle ABC, squiggly triangle DEF. What does the squiggly here mean?
It's congruent.
Look.
Similar.
Right here, a mathematical symbol indicating similarity between polygons is the tilde. So they're similar. Okay. Just find the scale factor of triangle DEF to triangle ABC and determine X. So we're going from triangle DEF to triangle ABC. So which lengths are going to be on top? The ones from DEF or the ones from ABC? Okay. So we're actually looking for X, right? We're trying to find X. So the ratio of X to what's the corresponding side over here? 11 would have to equal the ratio of two other corresponding sides. So does it matter which one we pick, do you think? No? So I'm going to pick 2 to 3. Could choose 6 to 9, doesn't matter. How do we solve this proportion? Cool. So cross multiply. 3 times x gives us 3x. 11 times 2 gives us 22. Divide both sides by 3. And so we get x equals 22 over 3. Or 7.3. We'll leave it as a fraction for this particular problem. Now, is that the scale factor? How do we get the scale factor? So since we know these are similar, then all we got to do is divide one of the sides of DEF by the corresponding side in ABC. So we could take either 22 over 3 over 11, or 2 over 3, or 6 over 9. Pick one of them. 2 over 3, it would reduce 2/3. No, so we have our scale factor. What is 6 divided by 9 if you reduce that, by the way? 2/3. And 22 over 3 divided by 11 gives us what? It better be 2/3, does it? Give us 2/3? Well, the calculators are very useful for it. No, this divided by 11. On a side note, when you're dividing with fractions, so if I do 22/3 divided by 11, that's the exact same as when we're dividing, we multiply by the reciprocal. Remember that from like 4th grade? So 22 over 3 times the reciprocal of 11, which is 1 over 11. 22 times 1 is 22. 3 times 11 is 33. 22 divided by 33 reduces to 2/3. So the scale factor is 2/3. Which means, in terms of size, the smaller triangle here is 2/3 of the size of the largest triangle. Yeah. Because this is this side, x, 22/3. And so this divided by the corresponding side. That's how we get the ratio. And then another couple of vocabulary things here, or just terminology things. Lots of times we use the words included angle and included side. And all it means is the angle between two sides or the side between two angles. So it says which angle is included between segment AB and segment BC in the drawing. So AB, BC, which angle is between those two? Angle B. That's the included angle between AB and BC. So which side is included between angle B and angle C? So angle B, angle C. So the side that's included is the one between them. So segment BC. So when asked about included angles, or when you see that, that's what it's referring to, just the ones that are between them. No, it's not consecutive angles. Different terminology. This is the included side. So if we say angle B, angle C, and the included side, then we're talking about angle B, angle C, and side BC. That's what we're talking about. It has nothing to do with consecutive angles. Mm-hmm. Yeah, I guess that you can make that generalization. Yeah. Okay, another example. Last example. It says if the lengths of the sides of a triangle are a ratio of 4 to 5 to 6, and its perimeter is 150 feet, what is the length of the longest side? Okay, so what this is saying, what this means, is that the lengths of the sides of the triangle are actually not 4, 5, and 6. They're 4 times the scale factor, 5 times the scale factor, and 6 times the scale factor. So they're all multiples of some other number. Okay? So what I mean is, here's a triangle. The sides are, according to this, are of a ratio of 4 to 5 to 6, which means this side I can call it 4x, this side I can call it 5x, and this side I can call 6x. In other words, they all share some common multiple. So if that x happened to be 7, then this side would be 28, this side would be 35, and this side would be 42. Okay, so this ratio, all it means is we can divide all of the sides by the same number. Okay, and we end up with these 3 values. But it also says the perimeter is 150 feet. How do we find the perimeter of a triangle?
You add all of them.
Add up all the sides. How do you find the perimeter of any figure?
Add all of them.
Okay. What about a circle?
Circumference.
So 4x plus 5x plus 6x has to equal how much?
150.
Has to equal 150 feet. Okay, now as you said, if we combine like terms, we have 15x's equal to 150. So divide both sides by 15, and so x must be 10. Now, is that the long side, the short side, or the middle side? So it's not the side, right? It's an x value. So to find the side length, we have to multiply each side by that x value. So this side is 60, this side is 40, and this side is 50. So how long is the longest side? Okay. The longest side is 60 feet.
So, Mr. Green,
Yeah.
So whenever they ask you like one of these questions, you just take the ratio and then put x5.
Yeah, so that's what this is saying, that each of these have some common multiple.
And you have to equal it to whatever it is, so if it was a different number, we would equal it to 280.
Right, exactly. If you think about it, like if we go back to like this first example, right? These are all have a common multiple of 2. Because our scale factor was 2, and we get back to these numbers. So if we said 11x, 9x, 3x, and 14x, right? And we wanted to get to this, x would have to be 2. So this is just relationship finding for finding the scale factor. So in this case, the sides are actually proportional to each other, not to some other figure. So in these cases, the sides of this triangle are actually proportional to each other. Okay. So there are 17 problems. None are super long. You've got the remainder of class to work on them. We'll be having a quiz tomorrow over ratio and proportion, which is Friday, and then over this assignment today.
Oh, no.
Okay.
And then